Hi everybody, welcome to sta220 Online. I'm going to recap. This is going to be a recap video of the week of October 5th. Last week you watched videos on sampling distributions. So I thought what would be a good idea for today is for us to go over the hand-in problems, since there seem to be some questions on the discussion forums. So let's get right to it. You can see the questions here on your screen. So the first one has to do with Melissa, social worker. And I won't read the whole scenario, but the first question says, there are 50 clients that are potential research subjects for Melissa's study, and we know the proportion of depressed clients is 20%. What is the sampling distribution of the total number of depressed clients? Well, the total number of depressed clients, let X is the total number of depressed clients, and since a client can be either depressed or not depressed, and there's 50 clients, we know that that has a binomial distribution with n equal to 50 and p equal to 0.2. Okay, what about the second one, part B? Part B, it says, how many clients would you expect to be depressed? Well, that's asking you for what's the expected value of the number of depressed clients. So the expected value for a binomial distribution is just the number of trials times p, which in this case is 50 times 0.2, which is 10. In part C, it's saying, what is the probability that at least 10 clients are depressed? So that is, what's the probability that X is greater than or equal to 10? Well, that's the same as 1 minus the probability that X is less than or equal to 9. And so we can go to our the distribution calculator and calculate that probability. So if we go here, probability and binomial, and then the number of trials is 50. The probability of success on each trial is 0.2, and the value of X that we're interested in is 9. And so that gives a probability of 0.4437. So that's equal to 1 minus 0.4437, and if you do the subtraction, that's equal to 0.5563. Question is, suppose that across the general population, the mean score on BDI is 45 and the standard deviation is 6. A person is considered severely depressed if they are within the top 5% of BDI scores. Then a new spot opens up in Melissa's study and she needs to recruit a participant. Alice scores 53 on the BDI. Is Alice severely depressed according to the BDI? Well, what we have here is that BDI follows a normal distribution with mean 45 and standard deviation 6. So Alice scores 53. So what's the probability of a BDI at least as large as, or at most as large as Alice's score? Well, that's the probability that BDI is less than or equal to 53. So how can we calculate that probability? Well, the first thing we should do is standardize. So the probability of BDI minus 45 divided by 6 is less than or equal to 53 minus 45 divided by 6. And that's just equal to the probability that Z is less than or equal to 1.33. And this is equal to 0.908. Of course, if we had the distribution calculator, then we wouldn't have to standardize. But if we just had a table, then we would have to standardize. Okay, what about part B? So that was part A. Part B is, what is the BDI score above which an individual is considered severely depressed? Well, so we want to find the score. So we want the score is X such that the probability of a BDI score less than or equal to X is equal to 0.95, because in order to be depressed, you have to be in the top 5%. Well, again, if we standardize, that's the probability that BDI minus 45 divided by 6 is less than or equal to X minus 45 over 6, and that's equal to 0.95. But now we can use the Z table. So that's the probability that Z is less than or equal to X minus 45 divided by 6 is equal to 0.95. So X minus 45 over 6 has to be equal to 1.64. And you can see that over here, if we go to the distribution calculator and we enter here, we look at the normal curve, and then we enter 0.95. So you can see that the value here is 1.644. So that value 1.644 is the area to the left of 1.644 is 0.95. So therefore X is equal to 6 times 1.64 plus 45. And if you work that out, that turns out to be 54.84. All right. So the next problem is, suppose Melissa is also interested in evaluating depression among the homeless population. She recruits 100 participants from a local homeless shelter and finds that their average BDI score is 51. Is there strong evidence of higher than average BDI scores in the homeless population versus the general population? So this question is kind of getting us a little bit closer to statistical inference, which we're going to be studying in the latter part of the course. So here for part C, the mean BDI scores for homeless is 51. And then the question is there strong evidence that this is different than in the general population? Well, we know in the general population, so in the general population, the mean BDI score follows a normal distribution with mean 45 and standard deviation 6 over 100, because that's the sampling distribution of the sample mean. Now, what is the probability that we would actually observe a sample mean larger than 51? So how likely is it that we'd observe something 50, like a sample mean of the BDI of 51 or larger? Well, again, here we could standardize. So the probability that X bar minus 45 divided by 6 over square root 100 is greater than or equal to 51 minus 45 divided by 6 over square root 100. That's just the probability that Z is greater than or equal to 10. And I don't need a distribution calculator or a table to know that that the probability that z is greater than or equal to 10 is roughly 0. So what this implies is that there's the chance of observing a BDI greater than or equal to 51 is virtually 0. And so that means that there's strong evidence that the mean score of BDI in homeless is different than the mean score of BDI in the general population, because we assume the distribution of BDI scores in the general population, and then under that assumption we calculated the probability of observing a BDI score greater than or equal to 51. We found that was 0, so therefore it's very unlikely that if those people came from the homeless population, if those people came from the general population, we would observe a score so large. Next week we're going to be covering, or this week you're going to be watching videos that have to do with data collection. And I look forward to seeing you next week online.